Hello everyone. Let's look at the multiple choice questions from the Limpopo March 2024 Physical Sciences paper. Question 1.1 says, the diagram below shows a woman at a shooting range. The woman fires at the target in front of her and immediately, involuntarily, sways backwards due to the shot taken. Which physics law can be used to explain why the woman sways backward after taking a shot? So Newton's law of gravitation, second law, third law, or first law. So to answer this question, we need to think about what's going on. So the woman's holding a gun, right? And the bullet goes forward. So the woman is holding a gun and the bullet goes this way, right? But the gun goes backward. So this is an action-reaction force. An action-reaction is Newton's third law. So the answer is C. Question 1.2. A 10-gram tennis ball traveling at velocity 2v to the right strikes the wall and bounces with velocity v as shown below. The vector diagram representing the initial, final, and change in momentum of the ball is indicated below with letters x, y, and z. Which of the following vectors, x, y, and z, represents the final momentum of the tennis ball? Now, this question often comes out in multiple choice exams, so it's very important that you practice questions like this. However, this one is easy, and I'm going to show you why. Because they are asking for the final momentum. Okay? Now, all we need to do is we need to consider the motion of this ball. So the ball goes here to the right, it hits the wall. So that can be regarded as the initial. And then it returns, but with half the velocity. So the arrow should be half in length. So that's going to be final. So if we are looking for the arrow combination here, or the arrow that would represent this, immediately we should look at y. Because y is pointing to the left, it's roughly half in length to z. So that's our answer. The answer is going to be y or B. Now, just for the sake of it, let's just go through what the rest of them are. So the initial is going to be z. So initial is z. The final, we said, is y. That means the change or the delta is going to be x. And it's important to do questions like this because they do often come out. Question 1.3. A bus with mass 5m collides head-on with a car of mass m. The bus experiences a change in momentum of x, east, due to the collision with the car. What is the change in momentum experienced by the car due to the collision with the bus? So if we had to just sketch this out, it's not perfect, but let's say it's the bus. And let's draw the car. So let's draw a car. Okay, here's our car. And let's assume they collided, right? Now the bus experiences a change in momentum x to the east, right? And we know that total linear momentum in an isolated system is conserved. So if the bus was x to the east, it means that the car must be x to the west because they would cancel. Or the overall would be 0. So the answer here is going to be B. Question 1.4. A velocity versus time graph describing the motion of a projectile is drawn below. Refer to the graph to answer question 1.4 and 1.5. So, which one of the following combinations is true for the direction of the initial motion and gravitational acceleration of this projectile? So, let's just draw. There's a cliff and there's a projectile. Now, we don't know if it's going up or down yet. But here's how we can solve it quite easily. If you look at this graph, this line, right? That is a positive slope. In math, we know that that is a positive slope. In other words, it is a positive gradient. And we know that the gradient of a velocity time graph is acceleration. So it tells us that the acceleration is positive. Now, the acceleration will only be positive if down is chosen as positive, because acceleration in vertical projectile motion is always 9.8 downward. So we can eliminate a few options here. We can eliminate A and we can eliminate B. That means we're left with C and D. Now, if you look at the initial motion of this object, the object starts at a negative velocity. And since down is positive, it must mean that the projectile moved up initially. So the answer here is C. Question 1.5, which physical quantity can be calculated using the area under this graph? So the area under a velocity time graph gives us the displacement. Okay, so that is something we learn. So the answer is D. Question 1.6, a ball is thrown toward the floor with velocity v from the top of a high building. So here, high building, there's the ball. It is thrown toward the floor, so it's thrown down. The contact time of the ball with the ground is negligible. Ignore the effects of air resistance. Which one of the following acceleration versus time graph is correct? Correctly represents the motion of the ball from the time it is thrown until it reaches a maximum height after it bounced off the floor. So upward is taken as positive. So it bounces. Right? So it bounces and it reaches some height. Now importantly, up is positive. So we know that acceleration is always 9,8 down. If up is positive, that means acceleration will be minus 9,8. Right? And we must always remember that this 9,8 down never changes. Right? The acceleration due to gravity is always 9,8 down for an object that is in free fall. So we are going to look for a graph where the acceleration does not change. So A is out and C is out. Now we're going to look at B and D. B has negative 9,8 as the acceleration. D has positive 9,8. We said that because up is positive, the acceleration should be negative. So B is our answer. Question 1.7. The following is the structural formula for an organic molecule. Which one of the following is the correct IUPAC name of this organic molecule? So I think it's clear to everyone, or should be clear to everyone, that this is going to be our longest chain. Right? But now the issue is, where do we number from? Do we number from left to right or from right to left? So we need to look at our substituents or the things that are attached to this organic molecule. We have a bromine, a halogen, and an alkyl group. So it's important that we remember this. Halogens and alkyl groups share the same priority. So you don't number from the right because it's a halogen, or number from in a certain direction because it's an alkyl group, right? That's for like those different rules will apply for like alcohols and so on. Now, because they share the same priority, we start numbering from the closest branch. So if I number from the left, the closest branch is going to be on carbon 2. But if I number from the right, the closest branch is going to be on carbon 1. So going from the right is the correct way. So if I go from the right, the first branch is going to be 1 bromo. And the only option that has 1 bromo is going to be A. Question 1.8. Which one of the following combinations correctly indicates the strongest intermolecular forces? Now, I've done questions like this before regarding intermolecular forces. I'm going to link them in the top right corner of this video. Here, you just got to remember, ethanol is an alcohol. And alcohols have hydrogen bonds. Ethanoic acid is a carboxylic acid. And carboxylic acids have hydrogen bonds. They actually have 2 hydrogen bonds. Ethyl ethanoate, since it ends in OH, tells us that that's an ester. Esters do not have hydrogen bonds, they have dipole-dipole. So the answer here is going to be B. Question 1.9. The melting point of a compound is the minimum temperature at which it boils? No, doesn't make sense. The maximum temperature at which it boils also does not make sense. The temperature at which its vapor pressure equals atmospheric pressure. That definition sounds familiar. That's actually the definition for boiling point. The last one. The temperature at which the solid and liquid phases of a substance are at equilibrium. That makes the most sense. That's the answer is D. Question 1.10. When butane is subjected to high temperatures and pressures, the following reaction takes place. Which one of the following represents Y? So, high temperatures and pressures is a clue that tells us that this reaction is actually a cracking reaction. And we know that during cracking, you will get an alkane plus an alkene. Right? Now, since we have broken up butane, butane is a 4-carbon alkane. Right? And when this broke, it broke into methane. We know methane is a 1-carbon. So if I had to cut this out, this is my alkane. So we have hydrogens here. So that means somewhere or somehow this must be an alkene. So we need to be looking for a 3-carbon, 1, 2, 3-carbon alkene. Now the number of hydrogens here is obviously not going to be correct, but we're just looking for a 3-carbon alkene. So let's look at our options. Option A, you have 1, 2, 3 carbons, could be correct. Option B, 1, 2, 3 carbons could be correct. Option C, 1, 2, 3 carbons could be correct. Option D has 1, 2, 3, 4 carbons, so that's definitely out. So the easiest way that we could do this is you have 2 options. You could either draw them out, right? And if you draw them out, you will see the double bonds. If you know the formula, that's another option. You could do the formula method. The formula method means you know the general formula for an alkene is CnH2n, and then you can just see which one matches the formula. So I think let's go with the formula method. So if we are looking for a 3-carbon alkene, right, that means N is 3. So it's going to be C3H2 times 3. So in other words, C3H6. So we want to know which of the options A, B, or C matches that C3H6. So if I count the hydrogens in A, I have 1, 2, 3, 4. So A is out. If I count the hydrogens for C, I have 3 plus 2, which is 5, plus another 3, which is 8. So that's going to be out. If I check B, 3 plus 2 is 5 plus 1 is 6. The answer is